we're going to be looking at the last two examples from the chapter 18 notes. So this would be on page 5 of your notes. So it says, what sample size must be used to estimate the outcome of the political election with a margin of error of 3% and 99% confidence? So what this means is we're looking at a margin of error of 0.03 and a confidence level of 99%. That's all we've been given. When we haven't been given a sample proportion, we assume p hat equals 0.5. That would mean that q hat equals 0.5. And this is just so that we're not favoring successes or failures. So I'll say that one more time. When we haven't been given a sample proportion, we just use p hat equals 0.5. And now we're ready to start plugging things into our equation. So our equation says that the margin of error is the critical value times the standard error. Okay, well, if I just write that again, margin of error equals critical value, and I know the standard error is square root p hat q hat over n. So when we start plugging these things in, you can find z star by using inverse norm on your calculator. If I have 99% here in the middle, the confidence level, then out here I should have 0.5% and 0.5% to give me that 100% under here. So that would just be inverse norm, and it's going to be 0.005 to stop at 0.5%. So I'm shading over here. It's going to give me this value. This value right here would be the one that I use in my equation. All right, so to finish this off in the calculator, it's standardized, so centered at 0, standard deviation of 1. And that gives you a critical value of 2.576. So we'll plug all this in. Margin of error listed above, 2.576. And now for p hat. Okay, and we are going to be solving for, well, how big does our sample have to be? Okay, from here, I'm going to take 0.5 times 0.5 and get 0.25. The square root of 0.25 is just 0.5, so I'm left with 0.5 over the square root of n times 2.576. It's going to lead me to my margin of error of 0.03. All right, from here, we have 2.576 times 0.5, 1.288 over the square root of n is equal to 0.03. I'm going to go ahead and cross multiply. Again, there would be a couple different ways you can approach this, but this gives me the square root of n times 0.03 is equal to 1.288. Divide both sides. Give you the square root of n equals 42.930. We're almost done. Our last step is going to be to square both sides. So n equals 1,843.027. But again, we're talking about people, so if I need 0.027 of a person, I have to take that whole person, so we always round up for these types of problems, these contexts. So I'm going to say I need 1,844 people. Okay, let's move on to this second question. So second question, we're looking at the true percent of left-handed people in the nation with 90% confidence. So my confidence level, that's a 9. And my margin of error is 0.08. Saying that it has been shown that in previous research, percentage of left-handed people was 38%. So that 38% is our sample proportion. So somebody else conducted some previous research. So there was a sample done, and it said that the proportion of left-handed people was 38%. So that gives us our p hat. So while we're at it, if p hat is 0.38, that means q hat is 0.62. Okay, so we'll go a little quicker through this one since we had a very, very similar example just a moment ago. So we have 0.08 as our margin of error. It's going to be equal to our critical value, which we look at confidence level to determine that, times the square root of p hat q hat over n. Okay, so 0.08. My critical value for 90% confidence is 1.645. You can use the same process we used on the example before this, or if you've memorized some of the popular critical values, that's fine as well. So in here, we have 0.38 times 0.62. I want to know how many people do I have to sample to obtain this margin of error and confidence level. So square root all of that. And we've got 0.08 equals 1.645. Square root of 0.38 times 0.62 is 0.485. The steps are almost identical. If you're having trouble with the algebra of, oops, left the square root off that. So the steps are almost identical to the example that I just showed you on the previous slide. If you're having trouble with the algebra from here, just come see me after school or at lunch. You should end up with n equals 99.5. We're talking about people, so I'm going to say we need 100 people, and that's my final answer.